Okay, so hi guys. I do apologize for the lack of videos. It's been crazy. I've been dealing with an earache for a while, but I'm on medication, so I'm hoping it goes away. So I want to do something different in this video, and I want to introduce the idea of basic, I guess, mostly arithmetic sequences when it comes to just arithmetic. But first, what I want to do is just define exactly what a sequence is and just some terminology before we actually get into problems. So a sequence is basically, it's just a list of numbers. So you can think of just, a random list of numbers. It can be 1, 3, 5, 7, etc. or like 2, 5, 7, 9, 11, 14, 17, etc. So that's just what a sequence is, right? It's just a list of numbers. And the idea is, when it comes to actually talking about arithmetic and how they kind of work, basically there's always a kind of formula that we use when it comes to actually writing an arithmetic, a formula for an arithmetic sequence or any kind of sequence. This is similar to when we were doing, especially when it comes to arithmetic, it's similar to when we were doing kind of finding the equation of a line given, a list of points. So as you know previously, if we were to have, I don't know, like 0, 5, let me think, give me a second. So if we were to have something like this, right, we would always say, and give me a second. Sorry guys, 1 second. 1 second. Okay, sorry about that guys. So if we were to do like, I don't know, for example, let's say we find the equation of this line here. So as you can see, it adds up by 4 every single time. So as y'all can see, and we know that the x terms are just increasing by 1 each time, right? So that was kind of the idea that, when you find the slope, it was always change in y over change in x. So we would always say it was 4 over 1, which is 4. And then from there, we would write the equation y equals 4x. And then we needed to find our y-intercept. We would pick a point from here. So let's say 1 comma 5, we say 5 equals 4 times 1 plus b, and then solve for b. And, that's kind of how we would figure out a relation here, like an equation, a pattern that defines, or an equation that defines this pattern. So we would always, we would end up with y equals 4x plus 1. So yeah, that was how we did it when it came to like x and y terms. But now we're translating that into actually, how to do it with sequences. So basically what, and actually what I kind of want to do here is not so much, because a series means that you're adding stuff. This is mostly sequences. So I'm gonna go ahead and just kind of introduce you guys to the idea of like the terminology, and then we can go over examples. So like I said, a sequence is a list of numbers. Most of them are defined by, so for example, if y'all have seen the term a sub n, we always read this as a sub n. So we would say a sub n, and then this just means like if we have, let's say, a t-chart and we have some number of n terms, and so the output would just be a sub n. So it's kind of like algebra in a way, but it's different notation here. We're talking about a list of numbers. And so, but we're not really talking so much about slope and y-intercept and stuff like that. It has nothing to do with that, at least not really. But we kind of, there's a relation there. Okay. Now, another thing I want to say is that anytime you see like the little variable here, it always is going to be your input. So kind of like input and output with a t-chart. It always defines what your input variable is. And then a sub n would be, or a sub anything, b sub n, r sub n, a sub k, etc. would be your output for whatever input you have. So it kind of, it is a lot like what we've been doing with algebra when it came to input and output, but it's now in a different notation, and you'll kind of see how, you know, some of these are very different. So let's start with an example. And for example, if I, you know, we always, and also another thing I want to say is that a sub n, so like a sub n, if there's a formula that's defined by this, then I would say that n is my nth, like basically it's my n number of terms. So this is my number of terms, whereas a sub n is really my nth term. So we always say that n is the number of terms, and then a sub n is whatever nth term we have from that. So this is called the nth term. So for example, if I were to say a sub n is equal to 2n minus 4, I know that whatever nth term I'm trying to find is defined by this equation. But for example, let's say if I want to find the fourth term, so if it asks me what is the fourth term, what is the fourth term of the sequence, or of the you know, of this arithmetic formula. And so I would say basically I would just define, I would say a sub 4, so a sub 4 is equal to 2 times 4 minus 4, right? So then I would do my arithmetic here, 8 minus 4, which is 4, right? And so I do believe that I've made a video kind of going over this. Give me a second, guys. I do believe that I went over a video on how to do this, or like on an example of this, basically. The only reason why I want to do arithmetic only in this video is because I kind of want to go more, it's a more specific topic. I don't want to do any other ones, but I will make a separate video over just what it means when we find the nth term. It just means that you're plugging in a number for that, and if it says find the first 5 terms, we would do a sub 1, a sub 2, a sub 3. But again, I do believe I made a video on that, and it is in my, I think in my Precal playlist. I can't remember, but I do have a video over that. So we're going to go over an example, another example. Let's say I have, and actually I'm going to go over an example that I was just talking about right now, where let's say I have a sub n equals, let's say 5n minus 3, and I say find, give me a second, guys, sorry. Okay, sorry about that, guys. So then I say, for example, let's say I say find the first I'm going to say 4 terms of the sequence. So obviously the way that we would do it is I would say, well, first what's a sub 1? I know that a sub n is 5n minus 3, but what would be a sub 1? So a sub 1, we just put n for, or 1 for n here. So we'd say 5 times 1 minus 3. So let's say we have 5 minus 3, and then we would get 2. So we know a sub 1 is 2, right? Now let's say we have, and so we want to do the first n terms, the first 4 terms. So I'm going to do a sub 2 next. So a sub 2, we're going to do 5 times 2, so we're just plugging in 2 for n, which is the second term, minus 3. So this gives me 10 minus 3, which is 7. So I know that a sub 2 is 7. And then I know that a sub 3 is going to be 5 times 3 minus 3, which is going to be 15 minus 3, which is going to be 12. So I know that a sub 3 is 12. So I know that that's my third term, and then my fourth term, which is my last term, right, would be, so we would do a sub 4 is equal to 5 times 4 minus 3. And this is just going to be like 20 minus 3, which is 17. So I know that a sub 4 would be 17. So we know that my first 4 terms are going to be 2, 7, 12, and 17. So I know that these are my first 4 terms, and that's how we would answer the question. This goes for any, not arithmetic, but any formula with a sub n. So it doesn't have to be arithmetic. It could be like a sub n equals 1 over n minus 4, or anything like that. It doesn't have to be arithmetic, but like I said, the reason why I'm doing arithmetic in this video is to kind of show y'all how this works. But that's just kind of what a sequence is, and that we can find the first n terms of it. Now, with arithmetic sequence, the only thing is, so like if we take example 1, the first example here that we just did, if we take this example and I go ahead and say that a sub 1, and I go ahead and list them again, so it's 2, a sub 2 is 7, a sub 3 is 12, and then a sub 4 is 17. I know that if I list out the terms 2, 7, 12, 17, I know that these have a pattern, right? I can simply look at this and say, well, if I go from 2 to 7, how much do I add? I add 5, right? So I add 5 every single time from 7 to 12, and then from 12 to 17. So this is kind of going to the kind of backwards here to kind of show y'all what I mean by the formula I'm about to introduce. So what we call this our common difference. So common difference is really just, it doesn't have to be subtraction, it could be addition. It's really, common difference is really how much am I adding or subtracting each time. So meaning, as I go from one term to the next, how much am I subtracting or adding or subtracting, etc. So here, like we said, we're adding 5, so we usually denote this. We usually denote this by D, because the letter D, so basically D would be my common difference. That's basically one of the parts that I'm introducing here. And at the very end, I'm going to introduce the equation as to what all of these letters are going to be put into. So then that's the common difference. We would denote that by D. It can be anything depending on the sequence. Now, A sub 1, so like if I write A sub 1, this means the first term of the sequence. So if I ask somebody, like, what is the first term of this sequence that I'm given? What is the first thing that I'm given here as I go? So I have 2, 7, 12, and then 17. What is my first number? That is my first term. So I know that here, A sub 1 would be denoted by 2 because that's the first thing I start with. That's the first number that I get out when I put, it's the first term. A term meaning a number, right? So I know that here A sub 1 can be denoted by 2, right? So I know that, like I said, this is my first term. I know that on my example, A sub 1 is 2. And like I said, 5 is my common difference. It doesn't have to be addition or subtraction. Okay, so then, and then let's say that I want to go plus ... or not, I'm sorry, not plus, but comma ... and then I want to do some number or some term A sub n, meaning that it's an nth term. We don't know what it is, right? Now, the way that this is defined, if I want to write a formula for this sequence, I'm going to use the following formula. It is called the arithmetic, let's see, hold on one second, guys. Okay, so like I said, guys, there's a formula for the nth term of an arithmetic sequence. So given that we have, it usually involves 3 things. So the first part is the A sub n. That is what we're going to define as our formula. It's defined by any formula that we have. In this case, because it's arithmetic, we would define it as arithmetic, since we're talking about arithmetic sequence. Now, this is going to equal the first term, A sub 1. So A sub 1 is my first term. So let me kind of label here A sub 1, which means my first term. And actually, let me write it down first, and then we'll go ahead and kind of define. And then plus D times n terms minus 1. So the way that we the way that I kind of want to label this is basically we know that A sub n is the nth term. So we know that this defines here our nth term. So let me write that down. A sub n would be my nth term. And then A sub 1 would be my first term. And then n is just the, it's really the, it's confusing to explain because I don't want to say it's the nth term. It's really the number of terms at what term we're defining. So give me a second. Okay, so I don't want to say it's the number of terms, but n is really the input. So I want to say n is really my input. So if I talk about, for example, the first 5 terms, the first nth terms, you know, I know that A sub n is my nth term, but n is really what kind of what value of n am I starting with. So I don't know how else to explain that. If somebody in the comments can explain it better than I can, please let me know. Or please do comment to correct me. But basically, I would have to give an example. Basically, it's the input of a sub n. So I'm just going to say that. It's the input of my nth term. It's what I would plug in for n, really. Now, and also it is the number of terms, so I don't want to say that here, but anyways, just know that it is the input of the nth term. So with that, and then finally, we know that, like I said, D is my common difference. So we know that, like I said, this is what we would put in for n, right? So n is the input of the nth term. So if I say a sub 6, I would put 6 for n. It just means the input. And then the common difference is just d, right? We know that d is my common difference. So it's just however much I'm adding or subtracting each time. So here we know that this is how we define these things. And so I kind of want to give an example over this. So let's say I want to do, let's say for example, I'm going to give an example where I say the first term of an arithmetic sequence is, let's say, 3. And then I know, and the common difference is, I'm going to say, let's say, for example, let's say 5, right? So, and then I say find the formula for the arithmetic sequence. So we know that we must come up with a sub n, and we know that the first term is 3, and the common difference is 5. So we have two things here. And like I said, we're going to go ahead and rewrite the formula. A sub n equals a sub 1 plus d times n minus 1. Sometimes you'll see it as a sub n equals a sub 1 plus parentheses n minus 1 times d. I don't like using that notation because it confuses a lot of people. I like to write it this way better. But anyways, we know that the first term is 3, so we can clearly say that this can be a sub 1. So I know that a sub 1 is 3, so I know that that is what I have for that. And then another thing is that the common difference is 5. So we know that the common difference is 5 for this. So we would go ahead and put d is equal to 5. So we would go ahead and say that, right? And so if I want to find an arithmetic sequence for this, what I would do is I would say a sub n equals, I know my first term is 3, so I'd say 3 plus, and then my common difference is 5, and then times n minus 1. So now I know that this is my arithmetic sequence formula, the formula for my arithmetic sequence. So then my final answer would just be a sub n equals, and we would go ahead and kind of do a little bit of algebra here, 3 plus, and then distributive property, basically, 5n minus 5. If we combine the like terms, we would end up getting a sub n equals 5n minus 2. And we know that this is the formula that's defined given what we were given. So, yeah, so basically, that is how we would do that first problem. So give me 1 second. Okay, guys, so we're going to do this last problem. Like I said, this is a very quick overview, or a very brief overview. I'm not going over a lot. Basically, let's see here. Sorry, 1 second, guys. Okay. Alright, so it says, so basically finding arithmetic sequence and common difference, given two n terms. So let a sub 2 equal 3 and a sub 7 equal -8. Find the common difference and the arithmetic formula a sub n. So we know that we have, and actually I should change this to formula, not sequence. Give me a second, guys. Okay, so here we have, it says let a sub 2 equal 3, so we know that a sub 2 is equal to 3, and then a sub 7 is equal to -8. So let me kind of go ahead and go over here and do that. And we know that the common difference, we want to find the common difference and the arithmetic formula. So, obviously we don't have that right now. We know two things. However, in order to find the arithmetic formula, or the actual common difference, D can be defined as, if we have a sub n, if we have two things, a sub n and, I don't know, let's do, basically, it's going to be the following: a sub 7 minus a sub 2 over -8 minus 3. So basically, this is kind of like that idea that I was talking about with slope. However, it's not going to always be like this with all the sequences in series. With arithmetic, yes, it will be, but not with geometric. So geometric will be a whole other topic, and we're not going to be able to apply this rule to the geometric ones. So anyways, we know that we have a sub 7 minus a sub 2, and then we would always do over those two things. So let's pretend there's a formula with two n terms, a sub n 1 and a sub n 2. I would say the following thing: the difference would be a sub n 2 minus a sub n 1 over n2 minus n1. That's the best way I can explain it, guys. If that confuses you, let me know. But it just means that you're finding the slope of this. So we know that for when n is equal to 2, a sub n is 3. When n is equal to 7, a sub n is -8. So we're just finding the slope. That's what the common difference would be. So here we go. We have -8 minus 3 over, and actually we're supposed to do 7 minus 2, sorry. Not the other stuff that I put down there. Over 7 minus 2. So then this would end up giving me -11 over 5. And so from here, we have found the common difference, which is -11 over 5, right? So I know that's my common difference. And so D is -11 over 5, right? And now we want to find the arithmetic formula. So again, I'm going to write down my arithmetic formula. A sub n equals a sub 1 plus D times n minus 1. So this would be a sub n. I know my first term, and actually, I don't know my first term, but I do know my common difference. So basically, I know it's going to be a sub 1, and then minus 11 over 5 times n minus 1. However, to find my common difference, I must use these two things together to find the common difference. Or I'm sorry, to find the a sub 1, the first term. And that's the hard part about this. So the way that I'm going to do it is that I'm going to use systems of equations to do this. So a sub 7, I know, is going to be a sub 1 minus 11 over 5 times 7 minus 1. And actually, we don't need to use systems of equations. We can just use what we have for a sub 7. So I know for a sub 7, the 7th term, I know that that's going to be negative 8. So I know that's going to be negative 8 is equal to a sub 1, and it's going to be minus 77 over 5. I'm sorry, minus 11 over 5 times 6. So it'll be negative 8 is equal to a sub 1 minus 66 over 5. And so we would go ahead and solve for a sub 1, right? So the first term, we would end up getting the following. And I think it would be negative 40 plus 66 over 5. And then that would give me... Okay, so I know that my first term would be 26. So, I'm sorry, 26 over 5, excuse me. So this would cancel out, and then we would end up getting a sub 1. And this would end up being 26 over 5. And then we know that this is my first term of this sequence. And so we kind of wanted to find the arithmetic formula. So like I said, apparently we do need the first term. So whether or not it asks you for it, you do need to find it in the process of actually doing this problem. So we would go ahead and end up saying that the following three things. So we had that my common difference was negative 11 over 5. So again, I would end up saying common difference would be negative 11 over 5. And then I also know that that my first term is, or a sub 1, right? My first term, a sub 1, would be, so we'd say d equals negative 11 over 5 for this. And then my first term, a sub 1, we would say a sub 1 would be 26 over 5. So, like that, right? And then finally, we would end up saying, we would say our original formula. So now that we have a sub 1, we can now say that my formula, we can now say that our formula, a sub n, would be a sub 1, so it's going to be a sub 1, 26 over 5, and then plus, and since it's negative, we would say minus 11 over 5 times n minus 1. Now you can go ahead and simplify this if you really want to. You can do distributive properties, so we have 26 over 5 minus 11 over 5 n plus 11 over 5, and this would end up being a sub n would be, hold on guys, negative 11 over 5n plus 37 over 5. And that would be it. Or you could just say this by itself, but it's really either or. If they do actually do it in terms of just distributive property, then go with that. But that is gonna be it for this video, guys. I really wanted to kind of show y'all a brief introduction to arithmetic sequences. And so that is kind of as much as I could come up with. Now series, for arithmetic series, it is a little different. So I will do a video on that. And I'm going to go ahead and do kind of infinite versus finite arithmetic sequences in series. And then we will go on to geometric. But I really want to make these videos just to get it out of the way, since I've never made many videos on sequences in series. So like I said, thank you so much for watching, guys. And with that being said, please like, comment, and or subscribe. And I really hope this helps, and I will see you guys in the next video. Bye, guys.